All right, everybody. So in this lesson, we're going to be talking about properties of logs. Now, with the properties of logs, you're either going to be doing something called condensing for this lesson or expanding. Condensing is making something shorter. Think of it like this. Expanding is making it longer. For example, if we say we have number 25, this is a condensed version. If we wanted to expand 25, we could say 5 times 5. This would be an expansion. Or we can continue to manipulate it, and we could say 5 times 5 times 1 times, for example, 8 to the 0th power. You could condense it or expand it. Condensing makes it smaller. Expanding just makes it longer and longer and longer. Now this is going to be related to properties of logs. Sorry, but you're going to hear me blow my nose a lot. My allergies are just going insane. And sometimes in the classroom, when school's in session, my allergies go insane. I blow my stinking nose all class too. All right. First thing I want to introduce you to something that's called the product property. Product means multiply. When you multiply, it's the same thing as adding. The product property looks like this. It says log of A times B equals, it's the same thing as saying log A plus log B. So on your calculator, if you were to do the example that I give you, let's say log 1,000. If it asks you to log 1,000, the example I say is, okay, log 1,000 is the same thing as saying log 10 times 100. Which is the same thing as, remember, when you multiply, it's the same thing as adding each one of these. It's the same thing as saying log 10 plus log 100. Let me show you. If I were to ask you the value of log 1,000, what is the value of log 1,000? When you do this in your calculator, you should get 3 because this is asking, remember there's an invisible base 10. 10 raised to what power equals 1,000? The answer is 3. This is also going to give me 3. Watch. This is log 10. If you do this in your calculator, it's going to be 1. Because it's asking 10, there's an invisible base 10. 10 raised to what power equals 10? So 1 plus. 10 raised to what power equals 2? There's an invisible base 10. 2. 1 plus 2 is 3. See, these two are exactly the same. This is called the condensed version. This is called the expanded version. When you condense, you guys can probably start a counting game of how many times you're going to hear me blow my nose while I do this. This sucks. Okay. When you condense it, it changes to multiplication. When you expand it, it'll always change to adding. For example, the example question I gave you is, I ask you, expand log A, B, 3. Which is the same thing as log A times B times 3. Remember, multiplication means addition. So this is the same thing as log A plus log B plus log 3. Sometimes people get confused and they say, well, what if there's a different base? What if there's, let's say, a base 7? Then it would just be log base 7, A base 7, plus log B a base 7, plus log 3 of base 7. Okay, we're going to get to some pretty in-depth expansions in a little bit, but I want to introduce you to 3 properties. First is product property. The second property is called quotient property. It's the opposite of this. Quotient property is, instead of multiplication, the opposite of multiplication is division. When you divide, you actually subtract. So when you condense it, it'll be in division. If you expand it, it'll be subtraction. The rule is, or the property is, if you have log A over B, it's the same thing as log A minus log B. Or it doesn't always have to be a negative after it. It could also be this. Negative log B plus log A. This is the same thing. The log that's next to the negative is your denominator. Your positive log is always that number, is your numerator. Okay, I give you an example of, what do I say? I say log 100 over 10 is the same thing as log 100 minus log 10. Let's see if this gives us the same value. The value of log 100 is 2 because 10 squared is 2. The value of log 10 is 1 because 10 to the first power is 1. 2 minus 1 equals 1. Does this equal 1? Well, let's look. 100 divided by 10 is 10. What's the value of log 10? Gosh. Oh, sucks. 1. Look, 1 is the same thing as 1. All right. Now, in the example, I ask you in the example to expand log 3x over 2. Expand it. Okay, this is, look, I'm going to break this up. This is the same thing. Remember, this has to do with the other lesson, or other property, the product property. This is the same thing as log 3 times x over 2. Now, when you multiply, you add log 3 plus log x, and this is the log that's on the bottom, so you put that as a minus over log 2. Okay. Now, the very last property, before we get into some a little more in-depth explanations. The last property is called the power property. Now, what the power property says, it's a very, very simple property. It says the power property is all about exponents. The property goes like this. If you have log a to the b power, this b is the same thing as going in front of it and saying b times log a. These two are the exact same thing. Okay, and the example that I have you do is I say, okay, fine. Rewrite log 10 of 10 squared. This is the same thing as this exponent goes to the front. Becomes 2 times log 10. Okay, well, let's see, these two should be the same. What is log 10 of base 2? The answer is 2 because 10 raised to what power equals 10 squared? 2. And this is 2 times log 10. What's the value of log 10? 1. 1 times 2 is 2. See? They're exactly the same. Okay, and then I have you take this and expand it. Pause the video, see if you can take this and expand it. All right, so if you pause the video, you should have taken this, understood that this was the same thing as log 5 times x squared over y. Remember, multiplication is the same as addition. Log 5 plus log x squared. This is a negative log. And you're almost done. This goes in front. And there you go. Now what I'm going to ask you to do is this. See if you can take this and bring it back to its original state to see that both of these are exactly the same. Pause the video. I'm going to get rid of this. And I want you to take this and see if you can bring it back to the condensed version, because you're going to have questions where it's going to say, condense this. Pause the video, see if you can bring this to this. All right, if you pause the video, first off, I would do this. I would notice that log 5, I would just leave log 5. And I know that the 2 in front of the log x is going to be an exponent. The next thing I would do is I have positive logs and I have a negative log. So I know that I'm going to have a fraction. My negative log is that number is going to go on the bottom. I'm going to get rid of that. These two are positive, so they're going to go on top. But remember, when I add, it's the same thing as multiplying. Boom. There you go. Okay, I'm going to give you some difficult ones now to try. I'm going to have you pause the video and try to expand this. Natural log x to the 4th y over 7th. Expand that. Just to let you know, natural logs work the same as basic logarithm. Same thing. For expansions and condensing. Okay, so if I have this, if I expand it, it's going to be natural log. This is going to be natural log. I'm going to go a little faster. X to the 4th is going to go in front. Plus natural log of y, because when you multiply, you add, minus natural log of 7. There it is. Hopefully you got that. Next thing, see if you can change this using the power property. Pause the video, see if you can. It should take you about 10 seconds. All right, if you pause the video, I could rewrite this as log x to the 1/2, because the 1/2 power is a root. Now this travels, boop, in front, and it becomes 1/2 times log x. There you go. Okay, I'm going to give you one more expansion, then we're going to do a couple of ones that we condense. Expand this. Log x to the 5th of base 2. This is very easy. This is only one thing. This 5 goes in front. 5 log x of base 2. Some people get tripped out with the base. Look, there's a base here. There's an invisible base 10 in every time. There's an invisible base 10. There's an invisible base e. There's always a base. As long as the base is the same, you just continue. Okay, I'm going to give you 2 more questions. The second to last question is going to be a condense. After I write this, See if you can condense this. Shrink this to the log of one number. Sometimes they put parentheses around. See if you can shrink that to the log of one number. Okay. You have a minus sign, you have positive logs, and they're all a base 3, so I'm going to say log of base 3, but I'm going to put a fraction. This is going to be 5 times 8 over 2. All right. Simplifying, 5 times 8 is 40. 40 divided by 2 is 20. And if you wanted to solve this on the calculator, you would say, or if you want to rewrite this in exponential form, it'd be 3 raised to what power equals 20. And I'm going to show you how to find that answer next class. Okay. The very last question. This one's going to be, you'll probably need a new piece of paper for this. I want you to condense this. And it's really simple, but it's going to look strange. Pause the video and see if you can shrink that to the log of one term. Okay? First off, what I'm going to do is I'm going to rewrite log, it's all of log 2. So I'm going to say log base 2. This is a negative log, so I know I'm going to have a fraction. This 3 travels here. And it becomes an exponent. Remember, whenever there's an exponent outside of an exponent, it is multiplication. 3 times 3 is 9. Okay. This 1/2 comes to here, and it becomes x minus 1 square rooted. Addition means multiplication. So x squared times root x minus 1, which is x squared root x minus 1. And this is the condensed version of this. What that means is if you were to plug a number in for x and do this on your calculator, it would be the same exact answer as if you were to plug that same number in for x and do this log on your calculator.